So let me share a screen here and clean this up. So last time we were adding UI elements to our game. The three main UI elements that I'm going to look at are the text sliders and buttons. And we were in the process of putting text and sliders for the points and health in our game. And so we had this HUD new UI script that controlled the sliders. Later we'll get the buttons that are interactive, but these are passive devices controlled by the scripts. So right off the bat, we have to remember to include using Unity engine.ui. This gives us access to the types, sliders, and texts, which I have public here. And I use the game object find by name function to find the objects in the scene with specific names. And then having found the object, I extracted the text and slider components from that object. I did this in the awake function, which is kind of like the start function, except it runs before the start function, and so finds these. Alternatively, if we weren't finding things, we can drop them manually into the public variables that are exposed in the inspector. The update function that assigned values to the texts and sliders, the point text.text and the health text.text. This is what actually displays in the text box. And we use those get health and get point functions that were in the player status script. And we found the player status by finding an object of type. And so we were looking for a component, a script of type player status, and we stored that in the variable player status. And this is a common thing that we'll see: the uppercase name for a type and the lowercase name for a variable of that type. Had to label our texts and then concatenate with the plus operator the get points from the player status converted to a string with the toString function. The value of the slider we just assigned with the player status get points. And so we have something that looks like this. We have our points and our health. And as I move around here, I get points, and down here in the lower left, I've got the win condition triggered here. And if I blow up bombs and go through the firewall here, I lose health, and it all shows. And I remind you that an easy way to keep things organized is to put them in a panel. So here's my panel that contains these texts and sliders. I've set the panel so that all of the anchors are in the upper left corner here, these little anchors, and with them together, this will not scale. It will stay the same size. There are other options that we can take. And I believe I showed you an example where I used the grid layout group as an alternative way of doing that. So all of that's pretty simple and gives us very powerful tools for displaying UI elements. So what I want to do today is add some glitz to the game. Right now it's pretty plain. We've got these white cubes and white balls, and the firewall is got some texture on it. But I want to dress this up with some explosions that deal with the damage objects, and I'm going to add gems for the pickups, something sparkly. And there's a number of different explosion frameworks. There's the Detonator, the one that I like best. There's also the Unity Particle Pack, the old 5X, and the newer one. And there are others that you can find for free. The gem shader that I like disappeared from the asset store, but I've posted it to my Google Drive, so you can find that here. And the other day I found the set of gems that actually uses the same shader. I'll show you examples of these in a minute. So these are the kind of resources that we might use to glitz up our screen, our game. And I believe that I've included the use of explosions and gems as optional bonuses in this week's assignment. So let me show you what that looks like here now that I've added these gems to the scene. And I think I have to stop sharing for a second and turn on original sound, because otherwise the sound suppression of this system makes it go away. You let me know if you can hear this thing. But if I play the game now, first of all, I have these sparkly gem things that I can pick up, and there's still no sound. Mute audio. Should be sound. Oh, I know what it is. Hold on.
We can hear a ringing.
You can hear it? Okay, yeah. I'm just putting it so I can hear it as well. So I have these little particle effects with sound that reinforce the fact that you've collected these little items, and my points are now up to 125. I've got bombs over here with big explosions on them, and the firewall has an explosion as well. Whoops. Stop. There we go. So it's a better game if you've got A, visual effects, B, sound effects, and C, sparkly items to pick up. So how do we do this? Well, first of all, let me mention this Detonator. This is Ben Thorpe's Detonator Explosion Framework. And it's kind of a tour de force of procedural explosions. These are not just particle effects. These are scripts that build particle effects on the fly. And it's actually something that you can build your own explosions with. It has a number of prefabs. The Detonator base is kind of the starting point for making your own, but then there are all these other prefabs that come with the system, and you can play with and see different kinds of explosion effects. And that's kind of cool. It has a test scene that you can play with and see what's going on here. And the code is readable if you want to figure out how they procedurally made particle effects. It's very cool. So what do we need to do to include these in our pickups? So in the pickup script on the little pickup objects, first of all, I've simply made them. I've given them a material. These little cubes that were originally white, I just put the purple diamond material on it that came with the gem setup, and then these are some of the gems that have the lavender diamond texture or material on them, and there's the gray diamond that has the gray diamond material, and these are all different meshes. Even though it says circle, it's not a circle mesh. It's this funny little cut diamond. So we've changed their appearance, but in the pickup script that goes with these, we've added a public variable for the detonator. And this could either be a game object, a capital GAME object, or a transform. Either one works. And into this, I put what it is I want to have occur when this thing is triggered. And I've picked this little sparkle effect here. The sparkle effect has a cleanup script on it so that it disappears after a certain amount of time, doesn't clutter up the scene, and it has a particle effect that makes the little particles, and it has an audio source for the ringing bell. And so this is the prefab that is instantiated when I trigger one of these pickups. And I do this by just adding the instantiate detonator, whatever that transform is that's in the exposed variable, at the colliders. Remember, we're in the on trigger where the collider, COL, is what ran into our trigger. And so this instantiates that particle effect at the collider's position, and quaternion identity just means that it's upright in the world. And the destroy game object was destroying the pickup object, the power up object. In damage, I can do exactly the same thing. I have a public transform detonator that is instantiated again at the collider transform position with the upright identity. And these damage objects, the firewall here has a detonator crazy that came from the detonator explosion framework. And of course, and I think some of these others, the pipe bomb here uses detonator upward, and so lots of different explosion effects that you can include here. I highly recommend it if you want explosions. So that's all very simple. Basically, 2 lines added to our damage and pickup script, the exposed variable for what we want to instantiate when the trigger is entered, and that's all we have to do. Bomb, the one for the rolling object, again, all we need to do is add a public transform for the detonator, and then instantiate that when the on trigger enter is tripped. Very simple. Now, this all is very simple, but there's some gotchas. And let me show you a scene where I haven't fixed the gotchas. This is test with gems and detonation nulls. And I want to watch the console over here while I play this, because something's going to happen here, I hope. It's an intermittent bug, and they're the worst kind. But I'm going to turn around here and drive through the firewall. And the other thing to notice here is I've got the error pause on. This means when an error occurs, it's going to stop the game. And I've actually got a null reference there already. But I don't want to show that one. I want to show a different one. So if I drive through this, I immediately this error pause occurs. And I'm seeing a bunch of different errors. Let me turn off the warnings, because those are from my scripts. And look at what this says. This says a null reference exception, object reference not set to an instance of an object in my damage on trigger enter at assets scripts my damage line 15. And if I click on this, double click on this error, it opens my Visual Studio, and it shows me the line where this problem occurred. It's line 15 here, and it's when it's trying to do a player status apply damage, and this is a null reference. Player status has not been defined. And I've inserted these debug statements. This is my code here with my Boolean debug that I can turn on and off. And with it on, with debug on, it's going to print the message that it contains the name of the collider that hit this thing. And so if I turn those warnings back on again, I see here first the FPS controller hit the trigger. That's what we expect to have happen. The FPS controller has the player script on it. But immediately after that, that debug message shows that a chunk clone has hit the trigger. And right after that is when I get the null reference. And that's because this chunk clone, which is just some little object that's produced by the detonator insanity, whatever this thing is, it makes a whole bunch of clone chunk objects that are little physical objects that it's throwing around through the scene. They're little cubes or something that are throwing around through the scene. And that's what's triggering the on trigger enter. And since this is not the player, it doesn't have a player status script on it. And so when it tries to access the player status script, it doesn't find one. It comes back as null, and the error occurs. So what do we have to do to fix this? We have to fix this. And what we do, there are a number of different ways to fix this, one of which is to test to see if player status has come back as a proper variable containing a player status type object. And if the get component fails, this player status is null. And so I can just simply test if player status, that is, it's not null, it has something in it. So if player status is not null, then we go ahead and apply points. So we're putting an error trap in here. And you can go ahead and run this if you don't have error pause on here. We can continue to run this and have it do all its stuff, and it's printing dozens and dozens of error messages. But if I if I include the error pause, it will stop there. Having this on is a good thing. When I grade you guys' homework, I turn the error pause on to make sure that your code is not throwing nulls or making various errors. So that's one way to do it. Here's another way to do it. You can test the collider to see if it is tagged as a player. So this way, our player, our FPS controller, is tagged to be a player. And so we can test the tag of the thing that collided with it to see if it's a player. If it is a player, then we would expect it to have a player status script, and we can go ahead and get the component and apply the damage, and everything is fine. Bottom line, you must protect against nulls with the appropriate error traps, because otherwise your game will throw all these errors and not be good. So I put these little debug statements in my code. I've got a little Boolean. I've got this little debug that I can turn on and off so that I can see the debug statements as they occur, and I can turn them on and off easily. And that's a good thing. And as I mentioned, there are three different kinds. There's the warning that makes these little white exclamations. That's just debug log. There's log warnings that make a little yellow thing, and there's log errors that make the red thing. And you can put log errors in your code and have the error pause on, and it will stop. So I should also do the same thing with the my pickup. The my pickup, I've got a my pickup over here somewhere that's kind of close to the firewall. Whoops. I've got a little pickup that's just on the other side of the firewall here. And so it's conceivable that one of those chunks, that one of those chunks might fly and hit that pickup object that's there in the little red cube. And so in the my pickup scripts, I've got to do the same kind of thing, player status null. The bomb script, if you remember with the bomb script, we had to do exactly this because the bomb was rolling on the terrain, and so it was constantly colliding with something. And so in the bomb script, we've already done this error testing where we've made sure that the player status was not null before we applied damage to the player status. You could also do this the same way with the making sure that the tag is player. So let me stop here quickly and entertain any questions about adding these special effects to our game. Sparkles with sound and damage objects with explosions. Okay, so let me go on to the next thing here. Oops. And the next part here is cutscenes. So in a proper game, let me quit this one. And while that's chugging, I'll load this. So in a proper game, we're going to have some opening scene. And in the opening scene, you're going to maybe have a character choice, or weapon choice, or the option to pick different levels, different scenes that you want to play. You might have instructions that tell your player how to play. And so we have this opening scene or maybe menu scene where choices are made. And this is what we're going to use buttons for. As the play progresses, we had those, we either won or lost. And instead of just having console messages that say you won or you died, we're going to actually transition to other scenes where we either congratulate our winner or we console our loser. And after we've visited these win-lose scenes, we're going to cycle back to the menu so that we can play again. This is very important. You don't want your win-lose scenes to be dead ends. You want your user to constantly be brought back into the game so that they can play and play and play. So we're going to have a start scene, we'll have one or more play scenes, and we'll have win scenes and lose scenes. And here they are. Here are my different scenes. I've got start, I've got 2 play scenes, I've got a dead scene and a win scene. And we're going to transition among these different scenes or levels with the scene manager. Now, if you're looking at old tutorials, you'll see references to the application load level. An application used to be how one transitioned among scenes, but the scene manager is the much more modern version of controlling scenes. It has a lot more power than the old application load level. It does require that we add a using to any code that wants to use the scene management. So like the using Unity engine.ui that we needed to add to have UI elements, to have scene management, to have the scene manager, we have to add Unity engine scene management to the tops of any scripts. So to start off with here, we could, if we only have one play scene, we can have our opening scene be pretty simple. It can maybe be some instructions, or in this case, all it does is has the text press any key that tells the user to go ahead and press any key, and it will enter the play scene. And I've done this with a text mesh object. This select level object in the game has a text mesh on it. This is what shows on the text mesh. Press any key, and there's various stuff like the font that you can pick and other kinds of stuff to make it go. And it has a start game script on it that is really quite simple. It's just if input any key, scene manager, load scene, and I'm playing the day game. So this is, and here's this using Unity engine scene management. So when I press any key on the keyboard, it's going to load the play scene. And so here, if I run this, press any key, and it transitions to the play scene, and I'm immersed in the game, ready to go and blow things up and collect points. So that's pretty easy. Input.anyKey responds to any touch on any key of the keyboard. Now, for this to work, the scene that we want to transition to has to be included in the build settings. And the build settings are over here under the File, pull down, Build Settings. And I've already got a bunch of scenes loaded in here. The way one adds scenes to the build setting is just to add open scenes. So I'm going to add this press any key scene to it, and it's now here and ready to go. And I'm going to delete that because I don't need it. The other thing to look at here are the numbers, because one of the ways we can load scenes is by their index number, and this is the index number. So if we load a scene by index, we'd be using that number. And the other thing is when we compile the game and make it into a playable executable that we can distribute, we want our menu scene to be scene number 0, because that's the one that'll start with a compiled scene. So that's the build settings. The other thing is to look at is the player settings down here. Well, first of all, I'm compiling for WebGL. I can also compile for PC and all of the other hardware. And the player settings here are, I'll mention later here, but these are things like the resolution, how big we want the width and height of the thing to be in the browser window, and then some other settings here that we don't really have to do much with. The defaults are generally pretty good, but there is some customization that you can do in there. So, to transition among scenes, the scene that we're transitioning to has to be in the build settings. That's a requirement. Otherwise, it won't work. It'll throw an error. Now, if we have more than one play scene, and we want our player to be able to choose among them, we might use a button feature. Having two different play scenes, I have two different play scenes. I have play day and play night. I have a day and night scene. But this is an easy way to have weapon choice for your character, or actually character choices. Just have identical scenes that have different characters in them, and the characters can have different weapons or powers or strengths or whatever. It's very simple to have different players in different scenes. So the game can be the same, but the character can be different in each of those different scenes. So in my start scene now, the start scene, I've now replaced that select level text with a little text that says select level. You could do this in the UI as well, but I've done it using this little object. And I have a canvas that has a panel that has two buttons in it, level 1 button and level 2 button. So you can anchor these however you want. I've picked anchors at the center, all 4 anchors at the center, and I've positioned the panel so it's kind of in the center of the screen underneath the select text, and it will not scale because the anchors are all together. I did some fancy labeling and coloring here so that my buttons kind of reflect daylight and nighttime, and the highlighting of the buttons is going to, my buttons have various colors that for the highlighting and the pressed conditions, for the normal color, highlighted color, and so forth. So I've done a little customization of the buttons. Now, the buttons are interactable. They're interactable. Check mark is checked, which means that they have the option to specify, to add events. And with buttons, you have an on-click event. When the button is clicked, this object, which is my select level object, has this select level script on it. And the select level script has load level 1. I'm going to scene manager play game. Load level 2 is going to load scene play game night. And you remember I mentioned you could also do this by the index in the build setting. So if I wanted to, I could load level by number with this argument. So this is kind of my script container that contains these public functions that can be called by the buttons when an on-click event occurs. And here in this case, I'm using the load level by number int, and when I use a function that has an argument, I get to see the argument here. So this is going to load level 1, index 1. I think this other button used the select load level 2, which was the other function that just directly loaded the nighttime level by name. And so since it doesn't have an argument, no argument shows here. So there are many different ways that we can do this. And there's also an option to load level by just having the string name in the argument. I think that's this example here, load level by name with a string argument scene name, and then load that scene name. We can load them with constants, just the string play game day. We can load them with a string variable, or we can load them with an integer level. Any of these three options work. So that's the buttons, and they work exactly as you would expect. If I load the daytime scene, I end up in the daytime, and if I load the nighttime scene, I end up in the nighttime. They're exactly the same scenes, but just the lighting is different. That's all that differs among the scenes. So the next thing we need to do is look at what we do when our player either wins or loses. And we're going to do exactly the same thing. We're going to transition to a scene. And in my apply damage, I had called these functions kill and win, depending if the health had gone below 0 or the points had gone above 100. And very simply, all I need to do is in the kill scene where it prints the message to the console, you are dead, which you could remove if you wanted to, I just load the dead scene. And if I've won, if I've added enough points to go over 100 and I win, I load the scene win. And of course, I have to add the using Unity Engine scene management to my player script in order to, my player status script in order to have this work. So that's all very simple too. Transitioning among scenes is very, very simple. So let me play the daytime scene here. And I'll quickly go and win. And I think I need one more point here to win. And it transitions to a scene where I've got a little text object that said you win. And notice it went back to the menu scene. I can show you that scene here. The win scene is a little object, you win, that has this text mesh on it that says you win. And it's got a little restart game script with a wait time. And the restart game script looks like this. It has my public float wait time, how long I want to wait. And I do this with a subroutine restart, which has the coroutines we'll talk about later, have this special type I enumerator, and they have the wait 4 seconds command. And it's complicated. We'll talk about this later, but yield return new wait 4 seconds wait time is going to wait for 2 seconds before it loads the start scene. And I actually have this here in the notes. So that's the coroutine approach to it. And coroutines have to be started with a start coroutine, and they have to have type I enumerator, and they have to have a yield statement in it, which in this case waits 4 seconds. And we'll talk about this a lot more later when we get to coroutines. There's an alternative way to do this that uses something called the invoke function. Invoke takes a string name of a function and a second argument, the wait time, and this will invoke this function after waiting for wait time. So invoke restarter wait time is going to wait 2 seconds, then invoke this function, which will then load the start. So that's another way to do it. Now, you don't have to be fancy with the dead scene, but I have, and so let me go back here to start. And this time I'll lose the game. I'll go into, I want it to maximize. So I'll go into nighttime here, and I'll just very quickly go back here and kill myself. And here's the lose scene. One of the things about the lose scene is I'm penalizing the player by making them wait for a while in the lose scene. I've got stuff going on so that they're not completely bored by it. And again, when I'm done making them wait, I transition back to the menu. This is key to keeping your player immersed in the game. When they lose, you penalize them a little bit by making them wait. That makes anxiety. And then throw them back into the game again and get them playing so that they don't have to restart the game. You definitely want to cycle back. And so the fancy stuff that I've done in here, I've got this little countdown script that instantiates 3D text objects. I made a prefab that's just a text object with a single letter in it. The text is set by the script, and I've added rigid bodies to the text objects and given them a little push so that they fall and rotate as they fall down. I did this again with a coroutine because I need to be able to wait during things. So here in start, all I'm doing is starting the coroutine count. Count has a for loop that counts backwards from wait time down to 0, incrementing I by 1, and waiting 1 second, then instantiating that number object that I've put in here for a game object prefab. It sets the text mesh. It gets the text mesh that's on that object with a get component, and it sets that text to be the counter I, which is counting from wait time down to 0, and it sets and it converts that to a string. When it's done counting down, it waits 2 more seconds, and then it loads the start scene. So that's what happens in our dead scene. We're waiting about 12 seconds here, making our user wait, and then starting up the menu scene again. For fun, I've got an explosion object in there, a countdown explosion. I've got the mushroom cloud, as it's a big explosion. It makes a lot of noise and blows up. And again, I'm doing this in a separate script. I could have done it in the same one, but I've done it in a separate script. It has an interval, a detonator, and a random range. It's run by this subroutine, coroutine count that, again, this is a while true loop, so this is just going to spin infinitely. And it picks an offset in this random range. So the position that it's going to blow the bomb up is not the same place every time. And it instantiates that detonator at the transform's position plus this random offset that I've thrown within the box that's plus or minus range. And I wait a certain number of seconds and then go around the while true loop. This loop never ends because the other script, this one, loads the scene start, and so it ends. So when I play this and lose, there's my mushroom cloud explosion. There are my text objects falling down the scene. And when this next one goes off, you notice that the text objects, which are rigid bodies, got blown away by the explosion. And so all that is cool. So I guess the message here is congratulate your users when they win, but transition back to the menu scene so that they can play again, because we want to keep our players playing. And when they lose, make them wait a little while to promote some anxiety, but entertain them while they're there, and then send them back to the menu to give them another shot at the game. So I'll stop sharing there and entertain any questions. This is what you're supposed to do for this Sunday's assignment, is a game of this ilk. It doesn't have to be a hard game. It can be fairly easy. What I'm testing in this week's assignment is the mechanics of being able to pick up objects and add points and counter objects that damage our player, have a UI that tells me the status of my player's health and points, and transitions among different scenes, including win and lose scenes, start menus, buttons, etc., etc., etc. So and don't just take my game and hand it in. I've had people do that. They just hand in the game that I post to my Google Drive. That's not the way to do this. But again, this is not the finished game that has to be very hard to play and long and difficult. We'll get to that later, the hard game, when we do our final project. Any questions? Let me look at
for button color. Is there a difference between highlighted color and selected color?
Yeah. Highlighted is what you see when the mouse is hovering over the button. Selected is what you see after you have pressed the button. And there's pressed button, which is what you see when you press the button. So yeah, there are 4 colors. And there's some options for transitioning among them. You can make it change gradually instead of instantly. And there are a lot of the UI is a TMO, too many options. The defaults are usually fine, and just leave them alone. But if you delve deeper into this, you'll find you can do all kinds of fancy things. If you remember in that sampler of the UI elements that I showed you at the beginning, when we did new UI, there was an oval button. So, the buttons don't have to be square, they can be round. And if you remember, the text in there was like red with a shadow and an outline. I mean, you can get real fancy. and do all kinds of great stuff. It's a very powerful tool.
Very cool.
Okay.
I'm excited to play with it.
Yeah, it's a lot of fun.
Awesome. Thank you.
Yep. Where are you that you have to, you're in the library?
Yeah. So it's better than my dorm. So
Better than your dorm? Oh,
yeah,
quieter?
exactly.
Okay. Well, these are strange times, and what are you going to